Look at this. It's 7 in the morning. It's cold outside, and this shower has been running hot water for 10 minutes without a boiler turned on, without a storage tank connected to the grid, without a gas bill that justifies even a single cent of this heat. How? With a black polyethylene hose, 4 zip ties, and a few square meters of roof or terrace that you probably already have. That's all. No moving parts. No electricity. No contract with any energy company. And here is the part that bothers more than one professional in the sector. This works not as a survival trick for emergencies, but as a real household installation that can cover between 60% and 100% of your domestic hot water consumption during the warm months, and a not insignificant percentage during the rest of the year if you live in a sunny area. The principle has a technical name, low temperature open circuit solar thermal collector. But before that name sounds expensive and complicated to you, let me completely break it down. Because what you're going to build today is not complicated at all. If this kind of practical knowledge is useful to you, subscribe to the channel right now. We publish real solutions every week to live better while spending less. A like also helps us reach more people who have never heard of this. The sun emits radiation. That radiation heats the surfaces it touches, and water, when it circulates slowly through a tube exposed to the sun, absorbs that heat with surprising efficiency. This is not a new theory or experimental technology. It is basic physics that the Romans were already exploiting more than 2,000 years ago. Roman baths used channels exposed to the sun to preheat water before it reached the boilers, and the first documented modern domestic solar collectors were installed in California in the 1890s. More than a century of history. What has changed is the price of materials. Today, a black low-density polyethylene hose, the cheapest type you can find in any hardware store or DIY superstore, has exactly the properties you need. First, the black color. It is not aesthetic, it is functional. Black bodies absorb almost all visible and infrared solar radiation instead of reflecting it. A black hose in the sun can reach between 50 and 80 degree Celsius on its outer surface on a moderate summer day. Second, polyethylene is a poor conductor of heat to the outside, which means it retains temperature well once the water inside is heated up. Third, water has a very high heat capacity. It takes time to heat up, but once hot, it maintains that temperature for a long time. If the hose has enough length and the flow rate is slow enough, the water that enters cold comes out hot. Physics, not magic. Wait, because here comes the number that people find hardest to believe the first time they hear it. In Spain, the average solar irradiation on a horizontal surface is approximately 100 to 100 kilowatt per square meter per year. If you install 20 linear meters of 20 millimeter diameter hose in a spiral over a surface of about 2 kilometers facing south with a tilt of 30 to 45 degrees, you can intercept enough solar energy to heat between 80 and 120 liters of water per day during the sunniest months. An adult needs approximately 40 liters of hot water per day for showering, washing, and basic hygiene. You are more than covered, and you have achieved it with materials that cost between 15 and 25 euro. I'm going to be direct, just like with the cost. This is what you need: black low-density polyethylene hose with an inner diameter of 20 to 25 milliliter. You need between 20 and 40 meters depending on how much water you want to heat. The price is around 0.40 to 0.60 euro per meter in hardware stores or DIY superstores. For 30 meters, you're at about 15 euro. Plastic zip ties resistant to UV. A pack of 50 units will not cost you more than 3 euro. A support surface, it can be a metal grid, a treated wooden panel, the surface of a flat roof, or even a bed of gravel painted black to maximize absorption. If you already have a roof or terrace, the support is free. 2 brass or plastic connectors to join the inlet and outlet of the hose with your home's water system, between 2 and 5 euro for both. A faucet timer or an adjustable flow valve to control the flow, optional but highly recommended, between 8 and 15 euro. Total, between 20 and 30 euro. If you already have zip ties, a support surface, and some connectors at home, you will probably stay around 15 euro. Step 1. Plan the spiral. Do not place the hose in a straight line. Coil it in a spiral or serpentine over the support surface. The goal is to maximize the length of tubing exposed to the sun within the smallest possible area. A serpentine with back and forth passes, separated by about 5 centimeters from each other, is the most efficient shape. Here's the first mistake almost everyone makes. They leave slack in the hose and loops form that move with the wind or lose contact with the surface. Secure the hose with zip ties every 30 to 40 centimeters, tightening it firmly against the support. The more of the hose surface is in direct contact with the warm support and the less exposed it is to the wind, the better. Step 2. Orient the installation correctly. Face it south in the northern hemisphere. Tilt it between 30 and 45 degrees relative to the horizontal. This tilt is not arbitrary. It maximizes the angle of incidence of the sun's rays during the central hours of the day, which are the ones that produce the most heat. If you have a flat roof, Place the hose on an inclined structure made with wooden slats or metal profiles. It doesn't have to be perfect, but it must be stable and not move. Step 3. Connect the inlet and outlet. The inlet must come from the domestic cold water supply. The outlet goes to the hot water tap or to a storage tank if you have one. The circuit is open. Water enters cold, travels through the entire serpentine heating up, and comes out hot directly to the point of use. The professional's trick is to install the outlet at the highest point of the serpentine and the inlet at the lowest. In this way, the heat itself generates natural thermodynamic circulation. Hot water rises and cold water descends to replace it. No pump, no electricity. Step 4. Regulate the flow. This is the most important adjustment and the one most often overlooked. If the water flows too fast, it doesn't have time to heat up and comes out warm instead of hot. If it flows too slowly, it overheats in the tube. It can generate steam on very hot days, and in installations not prepared for it, it can cause pressure problems. The optimal flow rate for a 30-meter hose installation on a sunny day is between 1 and 3 liters per minute. Adjust it with the flow valve or simply by partially opening the supply tap. In 2 or 3 days of testing, you will find the exact point for your installation. Step 5. Insulate the inlet and the first meter of hose. This detail makes a huge difference in the overall performance of the system. The connection between the cold water supply and the inlet of the serpentine, and especially the first section of hose before it enters the sunny area, must be covered with insulating foam for pipes. It costs less than €2 per meter, and prevents the cold water reaching the installation from cooling the first sections of the serpentine, reducing efficiency. Now pay attention, because this is what differentiates an installation that lasts 2 summers from one that lasts 20 years. The biggest enemy of black polyethylene is not heat, it is ultraviolet degradation. Under intense and constant sun exposure, standard polyethylene hoses become brittle in 2 or 3 years. They crack, split, and stop being useful. The solution? Buy hose specifically labeled as UV resistant or with anti-UV additives. It costs practically the same as the standard hose. Sometimes there's not even a price difference in hardware stores, but its lifespan multiplies by 5 or by 10. Ask at the hardware store for black polyethylene hose for agricultural irrigation. That type is designed exactly for this: sun, heat, and years of outdoor use. If you already have standard hose installed, you can give it a second life by painting it with heat-resistant paint with a UV filter. It is not the ideal solution, but it considerably extends its lifespan. If you've been watching this video for a while and still haven't subscribed, this is the moment. This channel exists to bring exactly this kind of knowledge to light: real, proven solutions that work and that do not require you to pay anyone to implement them. Give it a like and share the video with someone who pays more than they should for hot water every month. Let's talk about real numbers, because empty promises help no one. In summer, on a moderately sunny day, a correctly oriented 30-meter hose installation can raise the water temperature between 20 and 35 degrees C above the inlet temperature. If the supply water arrives at 18 degrees C, which is a typical spring-summer temperature in mainland Spain, at the outlet you will have between 38 and 53 degrees C. Perfectly usable for a shower without the need for mixing. In autumn and spring, with intermittent sunny days, the thermal gain is lower, between 10 and 20 cc, enough to preheat the water and significantly reduce the consumption of your conventional heater, although it may not eliminate it completely. In winter, in temperate climate areas such as the Mediterranean coast, the system continues to work on clear days. In inland areas with frost, the installation must be drained or protected during the cold months to prevent the hose from breaking due to freezing. A household of 4 people that uses 160 liters of hot water per day with a gas heater that consumes around 1.5 kilowatt per liter, heated, is paying approximately between 150 and 200 euro per year just for heating water, according to current rates. A well-executed solar hose installation can cover between 50% and 70% of that consumption during the warm months, translating into savings of 80 to 140 euro per year. You recover the investment in less than 3 months. Commercial solar thermal collectors work under the same principle as what you have just seen. The difference lies in efficiency, durability, and price. A commercial flat-plate solar collector costs between 300 and 800 euro per unit, plus installation, plus the storage tank, plus the pump and control system. We are easily talking about 2,000 to 4,000 euro for a complete certified installation. Return on investment between 8 and 15 years. The polyethylene hose, 20 euro. Return on investment, 3 months. Why is this not talked about more then? Because there is no profit margin in recommending a hardware store hose. There are no high value-added components. There is no annual maintenance service. There are no certifications that justify a 4-figure bill. I'm not saying that commercial systems do not have their advantages. Greater efficiency in adverse conditions, greater durability without maintenance, cleaner integration with the existing home installation. For many households, they are the right choice, but for millions of people, the black hose does the job just as well or better in terms of cost-benefit, and no one has explained that this option exists. A legitimate question. Is it safe to use water that has been in a hot plastic hose for showering, washing hands, or even cooking? The short answer, yes, with nuances. High and low density polyethylene is one of the plastics with the lowest known toxicity and is widely used in the food industry and in drinking water systems. At normal domestic use temperatures, between 40 and 60 degrees C, there are no significant migrations of compounds into the water. The nuances come with extreme temperatures. If the water overheats above 70 degrees, something that can happen on very intense summer days with very low flow, some low-quality hoses may release traces of plasticizers. To avoid this, use hose certified for drinking water, which already complies with European food contact regulations, and maintain enough flow so that the water does not remain stagnant in the tube under the sun for hours. If the water is going to be used for direct consumption, a basic activated carbon filter at the outlet of the circuit, the same type we described in previous videos, resolves any residual concern for less than 5 hours. What you have built is a functional and minimalist version. If you want to go further, there are simple improvements that multiply performance without blowing the budget. Glass or polycarbonate cover. Placing a transparent polycarbonate sheet about 5 centimeters above the hose, mesh creates a greenhouse effect. It allows solar radiation to pass through but retains the heat radiated by the hose. On windy days or in moderate temperatures, this cover can increase the outlet temperature by an additional 10 to 15 degrees C. The 100 by 200 cm polycarbonate panel costs between 10 and 20 euro. Insulated backing box, placing an insulating base, rock wool, rigid polystyrene foam, or even thick cardboard covered with aluminum foil. Under the hose, surface reduces heat losses downward and improves overall efficiency by 15 to 25% depending on conditions. Storage tank. If you connect the outlet of the serpentine to a storage tank, a 50 or 100-liter food-grade plastic drum works perfectly, you can store the hot water produced during the central hours of the day and use it in the evening or at night when the sun no longer heats. Cover the tank with insulating foam, and the temperature remains usable for 12 to 16 hours. With these 3 improvements, which together do not exceed an additional 50 euro, the basic hose installation becomes a compact solar thermal system capable of covering practically all the hot water demand of one person or half of that of a family of 4 during the warm months. What strikes me most about all this is the age of the knowledge we are recovering. The first documented solar water heating systems with exposed pipes date back to the 19th century. In 1891, Clarence Camp patented in the United States the first commercial solar water heater called the Climax Solar Water Heater, basically a black metal container inside a glass box. In Florida and California, thousands of units were sold before cheap. Widely distributed natural gas made them economically irrelevant in the first half of the 20th century. In Israel, where gas has always been expensive and the sun abundant, domestic solar heaters never disappeared. Today, 85% of Israeli households have some type of solar thermal system on the roof, not because they are more technologically advanced, but because they never stop seeing the sun as a free and obvious source of energy. In Spain, with more than 2,500 hours of sunshine per year on average, the potential is enormous, and yet most domestic hot water is still heated with natural gas or electricity, energy we buy from third parties when the sun is right there above us every day without sending a bill. If this video has changed the way you look at your roof or terrace, it has already fulfilled its purpose. Subscribe to the channel so you don't miss upcoming videos. We are uncovering practical, proven, and economical solutions that have been sitting in a drawer for decades while you paid unnecessary bills. Give it a like if you found it useful, and share it with someone who needs to see it. It's free to do so, just like the hot water you just learned how to capture. A black hose, 30 meters, 15 euro, hot water from sunrise, without turning anything on, without paying anyone, without asking permission. It's not a trick, it's not a promise, it's physics that has been working since before bills existed, and now you know how. See you in the next video.